Are you there?
Good morning, sir.
Good morning, sir.
Good morning, Muhammad. Good morning, Poonam. Am I audible to you properly?
Yes, sir.
Yes, sir.
Okay, okay, good. So in today's session, we are going to learn about the Verilog language. Okay. So as you have seen, while following the IC design flow, you have used the schematic entry, right? Means you have drawn the schematic for your particular design, and then you have followed that flow to that particular design. Okay. So in similar way, you can use a Verilog entry or VHDL entry. So what is mean by that? You can write a Verilog code for inverter, okay, or you can write a VHDL code for an inverter. So if you talk about these languages generally, Verilog or VHDL, so this is the hardware description languages, okay. So what is mean by that? So I will start with the history. So in the 1980, what happened? U.S. Army was in search of very faster logic for their fighter plane. The fighter plane name was like F-22. Okay, a Raptor, I think. Okay, the fighter plane name was F-22 Raptor. So they were searching for a very fast logic. Okay, before 1980s, all the designs were done manually. Okay, so transistor count was less, and so at that time design was not that much of complex. Okay, before 1980s, so manual design were there. So this US Army started one project because they were in need for this particular fighter plane for a faster logic, faster hardware. So they started one project, research project. Okay, so IBM was also part of that project, and after 2 years of research, they founded one language called VHDL. Okay, so this was the hardware description language, and at the same time, the fellow whose name was Prabhu Goel, he was Indian, and then he was working in the Gateway Design Automation. Okay, the company Gateway Design Automation. He was also working on the similar kind of language. Okay, so after 2 years, that fellow founded out Verilog language. Okay, so if we talk about history, so in 1984, that time Gateway Design Automation. Now that company is Cadence Design Automation. Okay, so Prabhu Goel and Phil, these two fellows have founded that Verilog language, introduced that Verilog language. Okay, and in 1995, uh, that language become IEEE standard. Okay, IEEE standard language for a hardware description language. Okay. So after that, some minor changes are there. Some new features have added. So in the 2005, they have added some features. Means language evolved after that. Okay. So in 2009, uh, the superset of this language, Verilog language, the system Verilog, they have founded this language. So if I talk about a system Verilog language, so it is generally used for the verification purpose. So you have created, for example, particular RAM. Okay, you have designed this RAM. You have designed this RAM using Verilog language, for example, I say. So Verilog can be used for the modeling of the system, right? So system Verilog can be used to verify this RAM. Okay, so it consists of features for verification and modeling. Okay, it's just like a C only, but if you compare Verilog and system Verilog, it has a feature related to the verification more. Okay, and if you see the today's VLSI industry in India generally, most of the jobs are related to the verification engineer. Okay, so those jobs are related to the verification engineer. So if you learn a Verilog, you can move to the system Verilog. Okay, and there are job in this domain. you are really interested in programming or verification kind of thing, so you can dedicate your time to this particular language, system Verilog. Because why in India this language is popular? Because in India, most of the VLSI jobs are related to the verification of the blocks. Okay, and designing were done in means like their main headquarters. Okay, so like that way, system Verilog has a demand. Okay, so this is all about the history. And if we talk about flow, okay, so we have seen the IC design flow for Cadence yesterday. So now this flow is about ASIC design. Okay, so ASIC means application specific integrated circuit. Okay, so have you heard about this application specific integrated circuit? Do you know what is this?
No, sir.
Okay, okay, okay. Have you heard about FPGA?
Yes, sir.
Yes, yes. So is FPGA is ASIC? Okay, I will tell you. So ASIC means application specific integrated circuit. For example, now you are using a cell phone, right? In that cell phone, that CPU, if you move out that CPU and if you place that CPU into your desktop CPU, will it work? Will it work? If you take out the CPU of cell phone and if you put into the desktop CPU, will it work? It will not work. Okay, because okay, it will not work because that particular CPU is designed for operating that mobile all these things. Hello. So that particular CPU is designed for that cell phone only. So he can perform this specific task. Okay. So like that way, that is the application specific integrated circuit. If you talk about the FPGA, what you can do, you write a code in VHDL language or Verilog language, and you put into the FPGA. Okay. You can use the FPGA means by doing the programming, you can use a FPGA like an encoder, or you can use a FPGA like a digital to analog converter. Okay, you can use a FPGA like means for any kind of application you can change its functionality, right? You can change that device, but application specific integrated circuit means, for example, whatever the chip you are using, for example, video processor chip. So that is the application specific integrated circuit in your cell phone. Okay. So we will see that flow first. So this is the ASIC design flow, and in today's part, we will see this part using the NC launch. Okay, so today's flow will be like I will introduce some basic concept of Verilog language. Then we will move to the programming kind of thing. I will show you means slowly we go means slowly. First we will see the basic construct. Then we will design some basic circuit using a Verilog language, and again that we will move to the further steps. Okay, so it will not be all theory. It will be theory come practice. Okay. So first, I will explain you about this ASIC flow. So for example, uh, if I am to design a ASIC chip for a video processor, okay, in your cell phone. So first thing will be what? It's chip specification. Okay. So chip specification. Yesterday I have told you. So it consists of functionality, area, okay, power, speed, or we can say a timing. Okay, all these things. So these will be the chip specifications. Okay, so after getting that chip specification, in any organization there are two teams. One team is design team. Okay, another team is verification team. Just change the color. Another team is verification team. So design team, what design team will do? Uh, Design team will try to write the Verilog or VHDL. If you are talking about Verilog, so design team, what it will do? It will write a Verilog code. So this code, after the synthesis, will produce the hardware which require for the video processor. Okay. So it will write a Verilog code for the video processor design team. Okay. So after designing, what happens? We need to verify that. Okay. Is it following just like what we have done for inverter, right? We have verified by giving the clock pulse, by using the V pulse to that, right? And we are seeing that at the output we are getting a inverted or non-inverted output like that way. So we are determining the functionality of that particular thing. Okay, so design team will write a Verilog code, and that Verilog code will be for the design video processor. Okay, or if you talk about AND gate, design team will write a Verilog code for AND gate, so that AND gate can be implemented in hardware. And verification team, what it will do? It will write the test bench. Okay. So what is mean by test bench? So after designing this video processor, okay. So there are some inputs to video processor and there are some output to video processor. Okay. So a verification team will write a test bench, means it will write a one coding file, okay, test bench file. It will consist of code only, Verilog code only, okay. But the work of that Verilog code is to test this video processor. So it will apply some inputs to this video processor, okay, and after that he will get the output here, okay, and he will match this output with the chip specification, means is it giving the desired output or not. Okay, so that thing is called as a verification. Okay, so design entry and functional verification, so these two part we are going to see today. Okay, designing and verification, right? So after doing this design and verification, the next phase is RTL synthesis. So what is mean by synthesis, right? So for a design, you have written a Verilog code, for example, in Verilog, they use module for design unit. Okay, module, video processor. Okay, some input output, and code will be there. And if I the end module. So between this, there will be the code for the video processor. Okay, and you have done the functional verification. You have checked that this code is right. It is giving the same functionality as we desired. Okay, so you have checked this. Now what phase in RTL synthesis? What will happen? You will apply this module. You will apply this Verilog code to synthesizer, which is present in any design automation tool. Okay, so you will apply this code to synthesizer. What synthesizer will do? Synthesizer will map this code to the hardware in terms of logic gates, okay, or flip-flops, means digital hardware. Okay, so it will map that code to the digital hardware, means whatever the code you have written, that will be converted to the hardware part. Okay, now after generating hardware also, we need to verify that is this hardware giving the same functionality or not. Okay, So here also in this phase only, simulation also will be done here also, gate level simulation. Okay. So after doing this, after doing all this, okay, for example, you have written the code for this video processor, okay, and you have mapped the hardware, you have tested that hardware. Now you need to do the partitioning of the chip. For example, uh, if I am designing a chip for a microprocessor, okay. So in the microprocessor design, as you know, there are RAM, ROM, particular microprocessor or cell phone microprocessor I'm talking about. Okay, so there are different RAMs, ROMs, okay, and other processing units are there. So what design engineer do generally? They directly take the standard cell. Means, for example, someone has designed the RAM, okay, and that RAM is available in the library, okay. That RAM is available in their project library. So he will not again design the RAM. So he will directly take that RAM design and place it in his project, okay. So what will happen here? This thing is called as a standard cell concept, okay. We have studied this in theory class, standard cell concept. So standard cell is having the fixed height and variable width, okay. So such a standard cells will be partitioning in this partition of the chip phase, okay. So a proper placement of this standard cell will be done here. So what is mean by the proper placement? For example, okay, so this is a chip, and here you have taken a RAM standard cell. Okay, so RAM standard cell you have taken, but and here there will be some like uh, like logic unit, okay, arithmetic logic unit. If you say here there is a ALU, okay. Now I have placed these two standard cell, one at this point of chip and one at this point of chip, okay. So what will happen? I need to connect this to this ALU, this particular ALU, right? Okay. But now if I observe that if I place this ALU nearer to this RAM, so what will happen? This line length will be get decreased. As you know, as signal propagates through the line, the path delay will get increased, right? Path delay will get increased. So if you keep this ALU closer to the RAM, what will happen? Delay will be minimum. Okay. So that kind of partitioning of the standard cell will be done here. Okay. So that is that phase, partitioning of the chip. Now you have designed the chip, but what happened after the fabrication? Due to the fabrication manufacturing defects, even if you verified your chip in all levels, even if you verified for timing, power, or area, due to the manufacturing defects, okay, due to the manufacturing variation, there may be a chance that fault will get rise into the fabricated IC. So this is a fabricated IC for a video processor, okay, and maybe fault may occur into this IC, okay. So what happens if you don't ready for that particular phase? So what will happen? The yield of IC will be very low, okay. So if the one fabrication unit is having that particular difficulty, all the ICs produced by that fabrication unit will produce the same defect, okay, will produce the same defect. So we need to, after the fabrication also, we need to test our IC, okay. So where we got the problem, like that way, okay. So first chip, you say if you are designing any processor or any new design, so first what you will do, you will check, you will verify that design in all levels, and you will fabricate that IC. But after the fabrication also, you need to test that IC, right? So for that purpose, design for test insertion DFT is inserted. Okay. So what is mean by design for test insertion? So there are like maybe you have heard about built-in self-test, right? Or you have heard about scan path registers. Okay. Then ATPG, automatic test pattern generation. Okay. So all this block, design of all this block will be embedded into the chip only. So after the fabrication of the chip, what we will do, we only apply certain inputs, okay, and we will check is it giving the desired output or not. Okay. For example, why these techniques are used, as this is a large chip, okay, and there are different blocks. This is a first, this is a second one, this is a third, and this is a fourth one block. Okay, and input is connected to this first block and output is connected to this last block. Okay, and if you see this, now here you can apply, for example, if I apply one here, I am sorry, if I apply 1 here, I am expecting that I will get 0 as a correct output here. But I am not getting 0. Instead of 0, I am getting 1 here. So what will happen? I need to find out that on which part of the chip there is a defect. Okay. On which part of the chip there is a defect, because this input is controllable. Okay. You can apply the input here and this output is observable. You can observe the output here. Okay. But what about this inside connections? Okay. Because those are not observable and those are not controllable. Okay. For example, if fault get occurs in this particular block, second level block, right? So how can you detect that? So to make this pin controllable means, for example, if I should be able to apply input to this block even after the fabrication, even if that input is inside the block. Okay, so like that way, these techniques are there: built-in self-test, scan path, and automatic test pattern generation. So which increase the controllability and observability of this particular block or any faulty block. Okay, so here each topic is very in depth, but I will try to give the introduction. Okay. So after that, there will be the floor planning phase. Okay. Planning means what? It's just like a blueprint of your chip. It's just like a blueprint of your chip. What is mean by that? Just like you design, you pre-estimate all those things like uh, design placement of the blocks and routing of the blocks. Okay, that kind of thing. So pre-designing kind of thing means where you can place the block and how you can estimate the delay between these two blocks. So like that way, floor planning will be done. Then next page is this is one of the same thing only, floor planning and like just like a blueprint of your house means you design a blueprint like here should be the that bedroom, here should be the hall, here should be the kitchen, like that way for a different blocks you design the chip. Now in the placement stage, what happens? Now you have determined this blueprint. Now you will actually place these blocks. Okay. So here I will place my RAM. Okay. Here I will place ALU. So like that way placement will be done. So while doing the placement, there are placement algorithms. Okay. Block placement algorithm. What is mean by that? They find out the optimum position for that particular block. Means for example, at this point for RAM I am getting less delay or less clock skew. Okay, so like that way, it depending on the clock generator or whatever the sources are available, like a VDD, ground, all those things. Okay, external supplies. So depending on those all parameters, these blocks will be get placed. Then next phase is clock tree synthesis. So what is mean by clock tree? So So in generally clock tree, what happens? This is a chip, and here is a clock source. Okay, some clock source, external clock source we will give, and here is a one block. Here is a second block, and all these two blocks should have the same frequency. Means they should be in synchronization, but this one block is nearer to the clock source and this second block is away from the clock source. So what will happen, there will be the clock skew. Means at this point, if I say at this point clock is present at t is equal to 0, so at this point clock will present at t is equal to 1. So because of that, what will happen in such a type of arrangement, there will be the functionality error or timing error. Okay, so there will be the timing error in this case, right? So clock tree synthesis means optimizing the clock tree. Means, for example, if this is a clock source, there are different methods like H tree and all those things. So here you can see. So if here is the clock source and here are these four blocks like 1, 2, 3, 4. Okay. So even if the clock signal is having some delay, that delay will be same for all four blocks. Okay. So at all four blocks, clock will reach at t is equal to 1. So even if the delay, this all four block will be in the synchronization. So such a kind of clock distribution methods are designed in this clock tree synthesis. Okay. So after doing all this block placement and clock tree synthesis, routing stage is there. Routing means connection. You have placed the block. You have placed the block. Now you are connecting that blocks. Okay. So like that way you are connecting the blocks. You are making the wiring connection, just like making a wiring connection between the components. So here we are making a wiring connection in routing stage. Okay. And in the last phase, there will be the final verification. As yesterday you have done DRC, LVS, ERC, etc. All those physical verification will be done in the final verification stage. And in the last, you will generate a graphic database system file which will be used by the foundry to fabricate the chip. Okay. So this is the ASIC design flow. Okay. Here each topic is in depth, but I try to give the introduction, little bit introduction about each stage. Okay. So this is about the design flow of the ASIC. Okay. So let us come to our Verilog language introduction. Okay. So are you following?
Yes, sir.
Okay.
Yes, sir.
So do you have any doubt up to this point? Okay.
No, sir.
Okay, good. So now we will learn about a Verilog language. So for any language, first thing is that is it case sensitive or not? So Verilog is a case sensitive language. So what is mean by case sensitive? Can you tell me? Have you heard about case sensitive term?
Yes, sir.
So what is mean by case sensitive?
Sir, if a variable name is small a, then it is not same as capital A, sir.
Yeah, good only. So here, this language is case sensitive. This small a is different than the capital A. So while writing a code, you be aware of this thing, okay? And most of the syntax in this Verilog language are adopted from the C language. So if you see the if else statement, if you see the case statement, okay, all these statements are available in this language, okay. Now extension used to save the Verilog file is .v. This is also important. By using a .v extension, you can save these Verilog files. Now, this Verilog can be used to model a digital circuit at 4 different levels. First one is behavioral, second one is data flow, third one is gate level, and fourth one is switch level. So what is mean by this? So first we will see these points. So what is mean by behavioral, data flow, gate level and switch level? Okay. Now if I talk about the AND gate, for example, if I want to design an AND gate chip, so what I will do, so this is an AND gate, right? So first thing is behavioral modeling style, okay? Behavioral model. So what do you think AND gate behavior is described by which table? AND gate behavior, if there is an AND gate. How can you describe its behavior? Okay, there are A, B are input and Y is the output. So using a truth table, I can define the behavior of the AND gate. Na? When 0, 0 is there, output is 0, 0, 1 is there, 0, 1, 0 is there, 0, 1, 1 is there, then 1. So this is a behavior of the AND gate. Okay. So if I write a Verilog code which follows the behavioral modeling style, means I will write a code like by using a case statement, like so case A, B, okay, and there are different combinations like 0, 0. When 0, 0 is there, Y should be assigned 0. Okay, when 0, 1 is there, Y should be assigned 0. You can use if else also. Okay, so like that way, and when 1, 1 is there, Y will be 1. So this kind of modeling of Verilog is called as a behavioral modeling. Okay. So all whatever the problem statement you are solving in C, those are following the behavioral algorithm, right? You, just like a C like a algorithm kind of thing. So you know the behavior of the problem task, okay? How to solve that problem. So that is a behavioral modeling style. Next is data flow modeling style. So what is mean by data flow modeling style? You represent this AND gate in terms of its logical expression. So what is the logical expression of this AND gate? What is the logical expression of this AND gate? Anyone? A and B, right? So when you write a code which describes this AND gate in terms of logical expression, that kind of modeling style is called as a data flow modeling style. And third one is structural. So what is mean by structural? So here there is only one AND gate. Now in Verilog, there are inbuilt primitives, okay, inbuilt gate. So there is an inbuilt gate for AND gate in Verilog, that is AND, okay, and I'm using instance name U1 to that. So I will explain this, what is mean by this primitives. So you and U1, the first is output and then are the input. So what is mean by that? I'm just using this gate directly, or if you have designed like this, in terms of logic gates, in terms of their structure, I will design this code. So if I say this, so here there are two AND gate requirement and one OR gate requirement. Okay, so I will use two AND gates. So first I have used U1. So second I will use U2. So this will be the Y1. This will be the Y2. So AND U2 Y2. So this is Y1 C T. Okay, and then if you talk about the next gate is OR. OR is having instance name U3. If I say this is a U1, U2, U3. So OR is having the output F and having the input Y1 and Y2. So this kind of modeling style of Verilog is called as a structural modeling style. So in terms of gate, I have defined this design. Okay. For example, if you say RAM memory, okay, there is a RAM memory. So there are different RAM cells. So this is a RAM cell one. This is a second one. So if I have designed for a one single bit SRAM, so what I will do, if I want to design a RAM which will be having 8 memory elements, so I will connect these 8 memory elements using a structural modeling style directly. If I have designed one single RAM section, so like that way you do the modeling. Okay, so that modeling is called as a structural modeling style. And if you talk about the fourth one, so fourth one is in terms of switch level. So in the CMOS, you represent this AND gate using a PMOS and NMOS, right? So this modeling is in terms of PMOS and NMOS. So if you see the inverter, there is a one PMOS and there is a one NMOS, and how they are connected. So that kind of modeling style is called as a switch level modeling style. Okay. So this is the 4 important modeling styles. I will show you how to code for this. So don't worry about that. Okay. And in Verilog, you can use a single line comment like this. Okay. And if you want to do the block comment, you can do like this. Slash star and then again star slash. So in such a way you can do the commenting. So there are white spaces also like tabs, new lines, okay, and those are ignored by the compiler. But in string, those blank spaces are not ignored by the compiler if you use that in strings. Okay. Now, just like any language, Verilog is having the identifiers. So name given to any design unit. For example, if you are designing SRAM, so I am saying SRAM underscore Chetan. So this will be identifier for my SRAM, right? So what are the rules for the identifier names? So identifier can contain the alphabets, digits, and special characters. But identifier must begin with alphabet and underscore. You can't start identifier with letter. Okay, sorry, digit. You can't start the identifier with digit. Okay, and all these identifiers are case sensitive. So if you see the identifiers here, you can see this is a my underscore or identifier, and this is here M is capital and O is capital. So these two are a different identifiers. Okay, and if I use a slash backslash before identifier, that identifier is called as escaped identifier because you have used a printable ASCII character into that. Okay. So just like a name to the design unit or name to whatever you are using, variables and all those things. Okay. So these are the identifiers. So just like any language, there are keywords. So what are the keywords in C language or any language, any programming language, do you know? So what are the keywords in the C language? What is mean by keyword?
Sir, if, for, case.
Void.
Yeah, good. So similarly, in Verilog, there are keywords like module, always, wire, reg. Okay, these are the keywords. So you can't use this keyword for your variable name, right? It will give the error. Similarly, uh, we will see this how this going to work. Okay, so simple keywords are there: module, always, wire, and reg. And for any language, one of the most important thing is how to define a number into the language. Okay, means how to represent the numbers. As you know, there are a size numbers and unsized numbers. So what is mean by this size number and unsized number? In size number, we give the what should be the size of that number. We prior means the designer will give the size of that particular number. And in the unsized number, we don't give the size for that particular number. Okay. So if we talk about a size number syntax, so it is just like first size is there, then one tick. Tick is very important. Okay. So what is mean by size? It's a decimal value which represent the number of bits present in the number. Okay. Then there is a base. Okay. So there are different base systems. Decimal. If you are using a decimal system, then there is a D for decimal. If you are using a hexadecimal system, then there is a H or capital H, like that way. Octal, binary. So like this way, after defining the size, one tick is there, then you define the base. Is it decimal? Is it hexadecimal? Is it octal or anything? Okay. Then you represent that number. So number space, okay, in the chosen base format. For example, if I want to represent 0, 1 binary signal, okay. So what I will do? First, I will mention the size. Size will be 2. There will be 2 bits, right? Tick. The base system is binary, so I will use B, and then I will use that number 0, 1. Okay. For example, if I want to represent this into hex, if I want to represent this into hex, so what I will do? So minimum number of bits required to represent the hex is how much? Any hex number. Okay, we will see these examples here. Then if you don't mention the size for the number, so that size for that particular number will be depend on the machine or simulator, what kind of simulator you are using. Okay. And if you don't mention the base for any number, the default base is decimal. Okay. So if I mention a number like 156, so that simulator will consider it as a decimal number. Okay. Here you haven't defined the size, right? So if you have defined the size like a 12 bit number in hexadecimal system 156, so it will consider 156 as a hexadecimal number. Okay. And 12 bits are required to represent this number, like that way. Okay. And when you don't mention this, don't mention the base or size, that size will be depend on the machine and number will be considered as a decimal number. Okay. This is also one important thing. And if you want to represent a negative numbers into this, for example, if I want to represent a negative 4, so what I will do? I will place minus sign before, then size of that number, tick B 0, 1. So this will be what? Negative of 1 number. Okay. So negative numbers are stored into the system in 2's complement form, because 2's complement is having single representation for 0. If you use any sign system like other sign systems like 1's complement or sign numbers, there are two different different representation for 0. Okay. For that purpose, they use 2's complement to store the negative number in computers. Okay. So here you can, this is the important thing. So here we can see some examples of a numbers. So first is 156. So here we haven't defined the size and we haven't defined the base also. So default base is decimal. So this is a decimal number 156. Now in the next, we haven't defined the size, but we have defined the base. Okay, so base is what? Hexadecimal. Now how many digits are there? A, B, 3, right? So how many bits will be required? Can you tell me? How many bits will be required? Hexadecimal. This is a hexadecimal number. So you just tell me how many bits will require. Okay. So for a
12.
huh?
12.
Yes, right. So automatically it will take 12 bits, right? I haven't defined the size here. So 12-bit system. Now, if you talk about the octal, so tick, O and 54. So this number is in octal. Okay. So similarly, other things you can see. Now here you can see, here I have mentioned the size. First I will see this. So here also I have mentioned the size. The first, there are 5 bits in number, and that number is it in binary, and that number is 10110. Okay, so 5-bit binary number. If you talk about this, so this is what this number represented by 12 binary bits. Number is in hexadecimal system, and that number is 7F3. So 12-bit hexadecimal number, right? So if you want to represent a 2's complement of 4, how you can represent? So 4 bits will be required to represent that number. Number is negative, number based system is decimal, and that number is 4. Okay. Similarly, you can see for a binary system, 2's complement of 2. So 3 bits will be required to represent this number. Number is in binary system, and that number is negative, and that number was 2. So 2's complement of 2 will be represented by this thing. Similarly for octal. Now, if you consider this last one, okay, so you tell me why this is not valid. This number specification is not valid. This is invalid syntax. Can you tell me about this?
Sir, before identifier name, there is hyphen, sir.
Yeah.
Dash symbol.
This is not an identifier. These are the numbers. Okay. So here you are talking about this, na?
Yes, sir. Yes, sir.
Because this is not a hexadecimal number, right? No, this is not an identifier. Okay, Mohammed. Identifier means just like you are giving variable names, right? Just like in other languages we use now. And in VHDL, maybe you are familiar with the VHDL. So in the VHDL, what we do, we give name to the entity, na?
Right,
So,
sir.
so that name is called as identifier. Okay, so you can't start that identifier with underscore or alphabet, but you can't start with the digit. This is the number. Okay, if I'm using this specification, so this is the number. But here what happens? It is saying that it is an 8-bit number. It is in hexadecimal, but that number consists of one hyphen, right? So because of that,
Right.
In hexadecimal, 0 to F are only there, na?
Right,
0
sir,
to
right.
F numbers are there. So that's why it is an invalid syntax. Okay.
Okay.
Okay. So there are in number specification, you can assign a value like X and high impedance value. So as you know, when we don't care about any input combination, we can give the X to that unknown values, right? So we have used in digital systems. So similarly, while designing your circuit or designing your design, you can use this X value. Similarly, you can use Z to represent the high impedance. So do you have any idea where we can use Z's value? Do you have any idea? Any application do you know? Okay, I will tell you. For example, if this is the one block is there, okay, and this block is having some input pins, and for example, this input pin is driven by some other block. Okay, this is a block 2, this is a block 1. Now this pin will be driven by this pin of block 2. So what this block will do, while designing this block, what I will do, I will put the value high impedance here, okay, for this input pin. So whenever input signal will come from this point, it will drive this pin. It will drive that to 1 logic level, or it will drive that to the 0 logic level. Okay, so this pin is driven by this block 2 pin. Okay, so like this way, while designing this block, I will put the value for this particular pin Z. So that can be driven by this block. Okay. So in such an application, you can use Z for a high impedance. Okay. Now, if the number is like 4-bit number in hexadecimal and like this. Okay. So what is the meaning of this? Just I need to increase the bits, 8 bits. Okay. So 8-bit number, hexadecimal, and X and F is there. So X means what? Unknown values. So 4-bit will be required to represent the F, and 4-bit will require to represent the X. Okay. And similarly, just like if the number is like XF, okay, so you can increase this X, no effect on the number then. Okay. Even if there is a Z, you can pad this Z on the MSB side. So no effect will be on this number. Only the size will increase. Okay. Just like if there is a binary number like this, and this is a positive number, so you can increase 0 as many times you want, right? Similarly, if this is a sign number, you can increase the 0 as many times you want on the MSB side. Okay. So you know this is in digital logic design. Okay. So just I have given the idea here. Now, there is an underscore like this, okay, which can be used to improve the readability, and which will be ignored by the compiler. So what is mean by this? We will see this, and this question mark can be used for the alternative for the high impedance value. So instead of Z, you can use this symbol also. Okay. So this symbol can be treated as high impedance value, right? So we will see some number specification related to that. So first example is the number is 12-bit in hexadecimal system. Okay. And you tell me now here how many bits will be required to represent the X? Okay, so here 4 bits will be required to represent the X. Similarly, 4 bits for this 4 and 4 bit for this one. So total 12 bits will be required. Similarly, in octal system 3 bit will be required to store one number. So number is 11 bit. So 3 for this, 3 for this, and now 6 are consumed. Now 5 are remaining. So 5 bits can be used to represent Z. Okay. So like this way you can do that thing. Now this underscore can be used to improve the readability. Okay. So here you can see that this 16-bit number is very readable in such a thing, and this will be ignored by the compiler. Okay. So this will be ignored by the compiler. It's just for the designer's point of view to improve the readability of this particular number. So if there is a very 32-bit number, 64-bit number, you can cluster that into 8-bit or 16-bit, and you can use underscore in between to improve the readability of that particular system. Okay. Then if you see this number, so here this question mark is used to represent the high impedance state. Okay. So here 10-bit number is there, number is hexadecimal. So 4-bit will be required for this question mark, this high impedance state. 4-bit will require for this high impedance state. Now 8 bits are consumed. Now what is the representation of 9 in binary system? 1001 na? Okay. So what will happen? 8 bits are already consumed here. Our number is 10-bit. So only these 2 bits will be get considered from the 9, and these 2 bits will be get ignored. Okay. So truncation will be done. Truncation of 9 is done here. So number will be treated like 1. So this will be number treated by the simulator. Okay. Because you have given the 10 bits only. So 8 bits are consumed by these two high impedance states, and this upper MSB will be get truncated. Okay, only these 2 bits will be get considered. Have you understood this point? This is also very important. Okay, ठीक है. So now we will move to the theory. We will move to the practice only, but I will just give the basic model how to design a model in Verilog. So that is basic design unit. So generally in VHDL. Okay, first, so in VHDL we have seen that entity is used, right, to represent any design. In Verilog we use a module, okay, and that module will be basic design unit in Verilog. Okay, so it is having some input and outputs. It's just like I am designing a module for a RAM. So I will use a module RAM input and output ports here, and between this module and end module there will be the code for the RAM. Okay, so and these ports, this input and output ports will be used to communicate with the other external world, okay, or other models. So we will see the syntax of module, and we will see the IO port directions, and then we will move to the code. Okay, so here you see the syntax for module clearly. So first it start with the keyword module, okay, then module name is given, then there is a port list, okay. So for example, if there is a AND gate module, so module AND gate, okay, port list is there. For example, for this AND gate, A, B are the inputs and C is the output. So what I will do, I have mentioned, I have used keyword module, then I have given the module name, okay, and then I have mentioned the port list, A, B, C. These are the input ports. Now, the next, after that, you need to give the semicolon. That is very important. Okay, after that, you need to give the semicolon. Then you need to define the input output ports. Okay, just like in VHDL we define input and output ports. Okay, so port direction. So first thing is port direction. Is it input port or is it output port? Okay, so here you can see there are port direction like a input, output, and in out. So here A is the input, A and B are the input. So input A, B, right? I have given the semicolon. Now what is the output? Output is C. I have given the semicolon. And after that, I need to define the functionality of the module and the local declaration, means whatever the local variable or local signal I am using in this module. But here only simple design is there. So there are two inputs and one output. Okay. So if I follow the data flow modeling style. So how can I write a code here? So assign is used for the concurrent statements, because we are not using a behavioral programming. So we are using a data flow programming. So assign C, A and B, semicolon, and module. Okay. So like this way I have written the code, but after the end module, don't give the semicolon. Okay. But after the module, you have to give the semicolon. So this is the basic thing you need to do for designing the model. Okay. So now we will move to the designing part. Okay. So I will show you how to open a terminal, how to create a model for this particular AND gate. Okay. So just connect to your AnyDesk. Okay, are you there? Just
Yes,
connect to your
sir.
system. This language part are important, otherwise you can't perform the programming. Now that's why I have given some basic idea about language and why we need to use. Okay. Okay, so Poonam, have you logged into your system?
No, sir.
Okay. Gauri, have you logged into your system?
Sir, I'm logging in.
Okay, ठीक है, good.
Like waking the remote AnyDesk client is offline. Trying to wake on by land.
Okay, okay.
This message is on my screen.
ठीक. Just a minute, we are starting your system. Now you can try to connect it, okay? Gauri.
Sir, my desktop screen is not visible.
Okay, Gauri, हाँ? ठीक है.
No, sir.
पूनम का डेस्कटॉप स्क्रीन is not visible. It is connected, I think.
Yes, sir. This desktop is not visible.
Desktop means you are not able to see anything on your PC.
Sir, now visible.
Okay. ठीक है. किया क्या हो चालू? सर्वर चालू है. ठीक है. Now come into this screen, right? Now create one folder here. So I'm giving here name Chetan _ Verilog. Don't give space, okay? While giving the name, don't give the space in between. Don't give the space in between, okay? So I have created this folder now. Click OK. Yes, Gauri, click OK. Now go into this folder. Right click, open in terminal. Okay. Right click and open terminal. So terminal is open now, right? So whatever the steps you have followed for invoking Cadence up to Virtuoso, okay, don't put Virtuoso. So I'm first typing CSH, enter, okay, then source space /home /install /CSHRC. Okay. Yes. Now you enter into the Cadence design tool. Okay, it is showing that welcome to the Cadence design tool. Okay, good. Now you type NC launch. Okay, don't hit enter. NC launch space hyphen new. Space hyphen new. Okay. Now hit enter. Now one window came, right? Okay. So this step we have done means you can invoke this tool NC launch using NC launch command also. But why we have used new? Because we are creating a new library. Okay. In that library, we will design our design. Okay. So now in this you can see there are like multiple steps, single step and other things. Okay. So click on multiple step. Now the screen is open. Here you can see I can maximize that. So here option is there, create cds.lib file. Create cds.lib file. Okay. Yeah, you click on that. After clicking on that, one window open, right? So it is just asking for the library file name. We are not changing anything in that library. So I'm just clicking on save. Okay. Click on save. Good. Now one window open. So it is having three options like include default libraries, which is for VHDL. Yeah. Create CDS lib.file. Create. Third option, sir. Yes. Save. Okay. Now here you wait. Okay. So there are three options like include default library, which is generally for VHDL or mixed design. Similarly, include IEEE pure libraries. Okay, so that is the second option. And third option is don't include any library. We want to design using a Verilog code. Okay, so select the third option. Okay, and then click OK. Okay, click OK then. Now this window opened, right? So this is the NC launch window. Okay. So here you can see there are no files, only work lib is there. So there is a no default editor present in this NC launch. So we need to use a Linux editor for this. Okay. So that may be gedit or any. So here we will use a gedit editor tool to write our Verilog code. Okay. So you can minimize this. You can minimize this. You can. Okay. Now come into the folder. Here. Come in your folder. Okay. Now here right click. Open in terminal. Okay. Now terminal is open. So yeah, good. Terminal is open. Now type gedit. Gedit. Oh, gedit. Okay. Gedit. I am giving a file name. After that, give space. After that, I am giving the file name and get .v because we need to create a Verilog file. Okay. Look at this carefully. Okay. Is my screen visible to you properly?
Yes, sir.
Okay, so I have written gedit and get.v. So if I hit enter, gedit will open. Now in this, we need to write a Verilog code. Okay. This screen is open now. So I am writing a Verilog code here. So first is we need to create a module for AND gate. So keyword is module. Okay. Then I am giving the name AND gate. Okay. So my AND gate is having two inputs and one output. So input A, B, and output C. Okay. Okay. So after then semicolon. So this is the first step. Semicolon is very important. Otherwise, it will give us the error. Now I need to define the input and output here in these ports. So there are three ports like A, B, and C. So I am using input A and B. Okay. Then I am writing output C. After every statement, you need to give a semicolon. It's very important. Otherwise, compiler can't detect that line. Okay. So after written this, I'm using assign. So this keyword assign is used for the concurrent statement. So this Verilog language support sequential statement and concurrent statement. So sequential statement means what? One after another execution will happen, right? So if I written like this, so if I written like this that A is assigned to the B, then so B is assigned to the A, then A is assigned to the C. So first this statement will get executed. After that, this statement will get executed. Okay. So this flow is called as a sequential flow. But our programming language is hardware description language. Okay. So it performs it also supports the concurrent flow or parallel execution flow. For example, if I'm using one always block here. So in VHDL, we use a process block, right? So in Verilog, there is a always block. So this is a always block 1. This is a always block 2. Okay. So these two blocks will be get executed at the same time at time t is equal to 0. So this kind of thing is called as a concurrency. Okay. Concurrent nature. So Verilog support this thing. Okay. So here I'm using a assign statement because I want to write the concurrent statement. Even if I write again, suppose if I am writing C is equal to A and B. Okay. So I have written this. Even if I write another statement here like assign, you don't write that. You only write C is equal to A and B. So even if I write another statement here like a D is equal to E and F, all these two statements will execute at the same time. Okay. So if I written D is equal to E and F here, both of these statements will get executed at the same time. Okay. So this thing is called as a concurrency. In hardware description language, that is very important. So after writing the functionality for this design, I will write end module. Don't give semicolon after the end module. That is very important. So I have written the end module. Okay. So here you can see the keyword is represented by different colors, right? Okay. So after doing this, press Ctrl S. Good. Now here you can see one create new document symbol is there, right? Click on that. So one document will be get open, right? So now after this, I have designed my AND gate. I want to do the functional simulation for that. So design engineer has designed this AND gate. Now verification engineer will write a test bench for it. Okay, so that we can verify that AND gate. So for the test bench, same thing. Module. Okay. Then I want to write a test bench for that. What happened, Shruti? Here you can click. Here you can click. Create new document. So other file will be open adjacent to that. Yeah, good. Now go into that file. Yeah. Go into the new file. Yes. No. Besides, there is like here this is the AND gate, and here this is that document, no? Yeah, only one file you create and enter. So again, I'm in that file you should enter. So I'm typing module, and this module will be the test bench for the AND gate. So I'm writing TB underscore AND gate. While giving the module names, you should be very careful that that name should be meaningful. Okay. So if you are designing any design, so that name should be there. And for that design, if you are designing a test bench, to TB underscore that design. So this will be clearly understood. So here, you without giving the port name, you can use this module. So after giving the name, you can put the semicolon, no issue. You can, okay. So now, if we see here, there are two inputs, input A and B, and one output is there, C. Now, in any language, there are data types. Okay. So what is mean by data type? What are the data types in C or any programming language? Do you know? Data types are there. INT. Have you heard about that in any language? Okay.
Yes, sir.
In Python, have you studied Python or C language? So
Yes,
there
sir.
is a data type, right? Similarly, in our language, there are data type. So we will cover that data types. So the two main important data types are register and wire. Okay. So this is a hardware description language. So its data type is like that only. So register means it is holding the value. Okay. And wire net data type is like a net or wire. That data type is, so I will just explain. I have a slide for that particular thing. So I will just explain that thing. So you will be very clear with that thing. That is important. Okay. So there is a net data type, Verilog. So what is mean by net? So this is the AND gate, right? And this is a combinational circuit. So if I say these are the input AB and output C, so this output is driven by this input, right? So whenever there is a change on this input, that will be get reflected by this output. Okay. So continuously driven by these inputs. Okay. So data type for this output will be net. Okay. And most commonly subtype for this net data type is wire. So this wire is driven by this AND gate driver. Okay. So data type for this is right. And here you can see if you don't assign any value to wire, wire value will be Z, high impedance state. Okay. And here you can see other net data types are also there, like WAND or try. So what is mean by that? So if I use two gates like this, okay, and this is I'm saying that this wire is S1. Okay. And if I define data type for this wire WAND S1, so what will happen? This wire will work as an ANDing of these two. Okay. Similarly, if you use OR S1, so this will work as a OR combination of these two wires. Okay, without using any gate. If you define a data type, it will directly perform its function like a WAND OR. And similarly, there is a simple wire function. So it will just work like a wire. Wire data type, not a function. Wire data type. So here you can see the example for wire. So wire is a data type for this particular wire. Temp1 is the name of that wire. So this is 1-bit wire or 1-bit net. Okay. And if you talk about a 4-bit net, so that will be wire and having the vector scaling, right? Vector coding 3 to 0. Okay. So this is a 4-bit wire having the name temp2. This is very important. Okay. So just like when you are using a 64-bit system, in 64-bit system, what will be the processing unit or what will be the ALU in that system? That will be a 64-bit, right? So that should be the vector quantity. That input should be the vector or that output should be the vector. So for that purpose, this vector porting is done. Okay. So this is about a net data type. In net, three important data types are, sub data types are wire, WAN, and OR. So these three are important data types in this. So this is most commonly used, wire. Okay. And then we will talk about a reg. So register, reg means register. So it's just like a storage element. Okay. So syntax for a register data type is, first we need to define reg. Then if that register is vector porting, if that register is having vector porting, then MSB to LSB. Huh? काय झालं? हा खूप डेटा टाईप आहेत पण यांना हँड्स ऑन द्यायला पाहिजे ना. Okay. So here you can see. So register is a data register. Okay, data type start with the register, or then there is a vector port MSB to LSB, and there is a register name. Okay, and this register can be always be used inside the always and initial statement. So this blocks always an initial block consists of sequential statement. We will see that point. Okay, so registers can be used only inside that part. So here you can see the example for register. So reg temp1. So temp1 is a register having a 1 bit. Okay. Similarly, this is a 4-bit register, temp2. So like this way you can define. This is unsigned. When you don't define the sign keyword before that, so that will be the unsigned thing. Okay. So these two are the important things. Okay, register and wire. Do you have any doubt about this? Have you understood this? This is very important. Okay, register and wire. So in our test bench, so this A and B, I will assign value to this A and B. So I'm using reg data type for A and B. Okay. And I'm using wire data type for C because I'm driving that wire by applying those inputs. So for a C, I'm using a wire as a data type. Okay. So now we have defined the AND gate design. Okay. So that design module also we need to take into this test bench so that we can apply input to that particular AND gate. Okay. So in this case, our AND gate is design under test. Okay. And this is a code for the verification. So we need to instantiate that AND gate here. So for that purpose, first we need to give the instance component name. This is also called as a component instantiation, means creating an independent copy of that component. So I am taking AND gate. So first I am mentioning AND gate. Okay. So this is the AND gate. Okay. And U1 is its copy. Okay. That is a copy of that AND gate. Right. AND gate U1 bracket. Now here you can see first in AND gate I have mentioned inputs. So A is the input, B is the input, and C is the output. Okay. So sequence of that is like first two are the inputs and then is the output. Okay. So similarly here also you need to do that thing. So this type of port convention is called as a positional port convention. So first I am mentioning inputs, then I am mentioning the outputs. Okay. And there is another thing like a naming port convention. We will see that later. Then semicolon. So what this statement do? It takes that AND gate and places into this code. Okay, so that we can apply input to that AND gates. After that, after doing that, we need to write a code for a test bench. We need to apply different input combinations. So for example, if there is an AND gate, we need to apply different combinations like 0 0 0 1 1 0 1 1. So like this way, okay? And we need to check the output in the waveform. So what I will do, I need to write a code for that. So there is an initial block available in the Verilog. So I'm using initial, okay. And in Verilog, if you want to combine many statement with each other, you need to use begin and end. Just like in C language, we use a bracket. If we use a condition like if A is equal to B, and after that there are statement to be executed, and we use a bracket to combine all those multiple statements. In Verilog, we use begin and end to this, okay? And between this begin and end, we will write a code which will be used in initial block. So first I am applying the input A is equal to 0 and B is equal to 0. Okay. Then I am giving delay. So you can give the delay of 10 units. Okay. Hash 10 I have given 10 units delay. Then I am applying A is equal to 0 and B is equal to 1. Okay. So here what is, okay, just a minute, cancel it. So here what is the meaning of this statement? So after 10 time units, if the one time unit is equal to 1 nanosecond, so after 10 time units, what will happen? This 0 will be assigned to A and this 1 will be assigned to the B. So this will happen after 10 time units. If one time unit is equal to 1 nanosecond, so after 10 nanoseconds, 0 will be assigned to the A and 1 will be assigned to the B. Okay. Similarly, I can give other combination. And A is equal to 1 and B is equal to 0. Okay. Then hash 10, A is equal to 1 and B is equal to 1. Okay. Again, I am giving one delay so that we can observe that input output. Okay. So like this way, you need to write a code. Give other input combinations also. Okay, I have given 0 1 1 0 1 1 and then again 1 0 time delay unit. So you write that code. Okay. After every statement, there should be a semicolon. ठीक है. Written? Okay. ठीक है. Now you can type Control S. Okay. Now here give the name TB underscore AND gate dot V. Okay. Then save it. So here you can see after saving all the keywords are visible. Right? Good. Now you can minimize this. Minimize it. And at the bottom of your window, there is an NC launch window available. So you just open that NC launch. NC launch. Here, at the bottom. Yeah, this window. right? So, okay, now here you can see two files are open here. And get dot what happened? Control आणि नाही तुम्हाला बाहेर यायचं. Okay. Here you can see two files are there. AndGet.v and tb_AndGet.v. These two files are get added into this system. Now, after doing this, we need to click AndGet.v and then click on this launch Verilog compiler with the color selection. Okay, so we need to compile this code. So I'm clicking on this. So here you can see in this console window, this is bottom one is the console window. So if you got any error, it will show you that into this. Okay. So you don't got any error. So it is not showing. Have you got any error? Error that is shown by the red color. Okay. Have you got any error? What happened, Poonam? Have you got stuck?
No, sir.
Yes, sir. After opening this,
After opening this, you need to click on AndGet.v. First file, yes. After clicking that, here you can see launch Verilog compiler with the current selection. Yes, good. Similarly, you can do for tb_AndGet.v. Okay. So it is showing some error, I think. End of file found while parsing the module tb_AndGet. So what error we got? So just minimize your NC launch and open your G editor. Okay. Here you can see in the initial we have started with begin and end, but we haven't ended this module with the end module. Okay, every module should be ended with the end module keyword. Shruti, Gauri, you can see that on the bottom there is a G editor opened. This tb_, yes, your screen. Similarly, so here you can see I haven't added end module there, so that's why it was showing that error. Now again you type Control S after putting end module, minimize this and go to the NC launch. Okay, now you select tb_AndGet.v and you do the compilation again. Now it will not show you any error. It is showing?
Yes, sir. Now it is showing an error.
How? Have you put an end module there? Have you saved that file? No, that was the previous. After every command, you can see that that was previous error. Only. Now it's showing clearly. So here you can see this is the right. Here you can observe. This is we are giving the running command here, compilation command here, NC launch. After this, you are getting some error. Here you can see my screen. I am not getting any error after this.
Expecting model name.
No, sir. After this command, I am getting error.
Okay. What
Which you
error
have
you are
highlighted.
getting? Okay, I am just checking. Just I am checking.
Expecting model name error. Expecting model name. सेव किया था आपने? सेव नहीं. G-edit में. G-edit sir last time. And model अलग अलग क्या लिखा है? एक साथ. हाँ नहीं. Okay. End module अलग अलग कोई लिखता है. Interface. सेव कीजिए.
Okay.
आया नहीं है
Okay.
डन हुआ
Okay, Shruti, here you can see here TP underscore and get module is there. Now you haven't put control S, right? You haven't saved this. Now if you go to pencil launch again, expecting just and get dot so and get dot P got a. Okay. Now you can TP. We have that for here we need to and dot B and then B combine. So I will not get okay. Okay, Poonam, you got any error?
No, sir.
Next one we need to see that. So you got error, right? Here these are the errors. Okay, expecting left parenthesis. Go to your PV and get dot V.
ये प्रीवियस है सर का ठीक है ना इसके सर देखिए ये इसकी देखिए इधर देखिए ये पावर सर देखिए ये आया ना इसके रेड कलर में तो है ब्लैक में है नहीं छोड़ दीजिए बाहर कंबाइन मत कीजिए हो गया आपका कंबाइन है फिर कंबाइन
Then again go to NC launch, click on TV and just go and
उसको भी सेव कीजिए गेट डॉट वी अब रन करें ठीक बात ठीक है ठीक है ना देखा ये कौन है देखिए ठीक है डेवलप कर रहा है अरे ठीक है क्या आ रहा है जैसे छोड़ रहा है
initial spelling is checked. You are wrong. So you have typed wrong initial spelling. Okay. Poonam. Now you
Yes,
can
sir.
save this. And again go to TV underscore android dot v. And here you can see now there is no error. No one got no error. Okay.
सर इसका जैसे इनिशियल चेक करना पड़ेगा इनका स्पेलिंग को
एंड नहीं क्लोज करता
एंड क्लोज करा ये सब मैंने म्यूट किया था माउस काम नहीं कर रहा मैंने म्यूट किया था ठीक है म्यूट हो गया लेकिन किसी आवाज नहीं आई क्या सर
रुको किसका चालू है फोन
ये वाला चालू है खाली इसको दूर रखो इको इससे
अरे एनीटेक्सच्या फुल फॉर्मॅट मध्ये बघूया गेलो ते मला आता बाहेरच आहे ना एनीटेक्सचं फुल विंडो क्लोज करायची लागली काय आहे?
हां
काय
तो वरती हमारा ऊपर स्क्रीन खींची अल्ट नहीं स्क्रीन ऊपर खींची हाँ हाँ है अल्ट और टैब क्या बोला अल्ट और टैब
नाही ना पण
है सर
फुल
हो जाएगा 332 अब करें
नहीं वो मुझे फुल स्क्रीन मोड ऑफ करना है
हाँ हो जाएगा अच्छा व्यू मध्ये जा डिस्कनेक्ट करा
कुठं
डिस्कनेक्ट करा ना, फिर से कनेक्ट कर लेंगे.
अरे नहीं ना.
त्यांना फुल व्ह्यू मधनं बाहेर यायचं आहे ना.
हाँ ना.
इसके बटन करा ना.
नाही हो ते केले नाही.
मला डबल क्लिक करा, जसं फुल स्क्रीन केलं.
हा हा, डबल क्लिक करा
कशावर?
स्क्रीनवर वरती.
परत एकदा.
नाही ना.
राजू फुल स्क्रीन.
अरे वो दिखता नहीं क्या है.
तो आप इसको
वरती.
सुनो सुनो, एक टक्का इसको डिस्कनेक्ट कीजिए. डिस्कनेक्ट कीजिए, दोबारा कनेक्ट कीजिए.
नाही नाही, राईट क्लिक करा बरं वरती जाऊन. काहीच येत नाही.
नहीं भाई.
सुनिए, कनेक्ट कीजिए, आप डिस्कनेक्ट कीजिए, हम बता रहे हैं. डिस्कनेक्ट कीजिए. 2 मिनट खेले, डिस्कनेक्ट कर देंगे.
तो वो सेशन में कुछ तो प्रॉब्लम.
नाही होते आहे माझ्या पीसीला झाले. तुम्ही तिकडे कंट्रोल करू राहिले का?
हाँ, मध्ये गेले का सर? कंट्रोल दाबून
फुल स्क्रीन.
डबल क्लिक करने से ऊपर आ जाता है. हाँ सर.
ठीक है छोड़ दो, कुछ नहीं अभी कर देंगे. अरे नहीं बट इसमें नहीं आ सकते ना मेरे.
कसं गेलं ते फुल स्क्रीन?
तिथं होतो ऑप्शन नाही काय बंद आहे ना हे माहीत.
त्यांनी मोबाईल नाही तरी.
हेलो सर ये बता दो कि थोड़ा प्रॉब्लम आ गया है.
मोबाईल से आप टेक्निकल
क्या कर रहे हो? Yes, participant, wait for 2 minutes. That is connecting again. Some connection loss. So do wait. Okay.
तो एक बार आलाय सर कुठला तरी.
अरे लाइसेंस करा ना.
अरे नहीं हो रहा है डिस्कनेक्ट.
सर एक लास्ट ट्राय बघा, इकडे बघा. कंट्रोल दाबा आणि
कंट्रोल आर डिलीट.
नाही कंट्रोल 10 करा, कंट्रोल आर डिलीट.
हाँ टास्क मैनेजर भी भाई. पण आता या सिस्टम मध्ये
टास्क मैनेजर आएगा कंट्रोल. अब यहाँ फोर्सफुली क्लोज कीजिए एनएडीएस में, तभी फिर डिस्कनेक्ट कीजिए. है ना?
आया भाई.
आला आला.
हे असंच मोड पाहिजे होतं ना.
नाही नाही
ना रेजोल्यूशन काय नाही.
रिझोल्यूशन नाही.
त्यांचं फुल स्क्रीन झालं.
फुल स्क्रीन झालं.
हाँ एंड स्टॉप में सर F5 सिलेक्ट कीजिए एंड टास्क. प्लीज वेट. नाउ इट इज करेक्ट. नाउ अगेन लॉन्च योर एंड टास्क.
इथं असतं का फुल स्क्रीन?
नाउ इट इज करेक्ट. ओके नो प्रॉब्लम. गो टू लॉन्च एंड टास्क. क्या स्टूडेंट भाग जाएंगे.
म्यूट करायला जरा.
माझे घरचे तर मारायला लागले.
पेशेंस नहीं होता. इसमें से कोई है नाम बहुत है. लास्ट में क्या है? लास्ट में 85 एक्सेप्ट सिस्टम. एक्सेप्ट सिस्टम रन किया.
अरे ये तो चालू ही था.
नो प्रॉब्लम. काट दीजिए.
मुझे आवाज नहीं आ रहा ना.
वॉल्यूम प्लस करना, मैंने माइनस कर दिया. अब आएगा. ठीक है. आपकी बोल सुन रहे.
हेलो एम आई ऑडिबल टू यू?
Yes, sir.
Yes, sir.
ठीक. हाँ now here you can see where we are there. हाँ here. So we done the compilation of these two files, AND-gate and TB_AND-gate. Okay. So here you can see after the compilation, two models get added, AND-gate and TB_AND-gate in work lib. Okay. So what we need to do, we need to go to the TB_AND-gate. And there, here you can see the launch elaborator with the current selection. on the upper. Launch elaborator with the, what happened, Shruti? Gauri. Gauri, are you online?
Yes, sir.
So you are following the flow now correctly?
Yes, sir. Yes, sir.
ठीक. So now you click on TB underscore AND gate file here under the work clip, and here you can see launch elaborator with the current selection. Okay, so click on that launch elaborator with the current selection. Okay. Now here you can see what is mean by elaboration. Elaboration means whatever the design under test we have used, means in the TB underscore AND gate, we have used this design under test AND gate, and this design under skates will be taken and input will be applied to that kind of thing. Okay, so input port will be get assigned, means elaboration will be done. Okay, so for that AND gate, input and output will be get assigned. Okay, for a design under test. So that thing is called as a elaboration. Now after the elaboration, here you can see if you click on the plus of the snapshot. Okay, so there one snapshot get added, TB underscore AND gate module. Okay, click on that. Have you click on that, Poonam? Okay. Now here you can see launch simulator with the current selection. Click on that. So now close this Cadence Indigo screen. Okay.
Close the screen.
Now here you can maximize this screen, no issue. Under the simulator tab, here you can see TB underscore AND gate design is get added. Okay, so this is a design browser for this sim vision window. Okay, so I click on this, then right click, okay, and send to waveform window. Right click, send to waveform window. Click on that, send to waveform window. Now one window will open. So this is a waveform window. Here you can observe the waveforms. Okay. So now here you can see two inputs are there, A, B, and output is C. Okay. So at this point here you can see play like button is there, then blue color play like button. Okay. So here I am noting that blue color play like button is there. Now click on that. Okay. So now here you can see the waveform came. For whatever the input you have applied, you are getting some output. Okay, for that particular design. So if I click on this, one marker will come. Okay, so if you directly click on that point, particular point, या ऐसे क्लिक कर दो, ऐसे मूव होता है फिर वो मार्कर. ठीक है, वो क्लोज कर दो जो आया है वो जो पॉपअप आया है वो क्लोज कर दो. So here you can see between 0 to 10 nanosecond, when inputs are 0, 0, AB inputs are 0, 0, output is 0. Okay. Similarly, if you see between 10 nanosecond to 20 nanoseconds, so in test bench what we have done, first we have given the 0, 0 inputs. Okay. Then we have given the 10 time units of delay. So from 0 to 10 nanoseconds, input will be 0, 0 only. And after the 10 nanoseconds, A will be 0 and B will be the 1. So here you can see A is 0 and B is 1. And for this, we are getting 0 output. Similarly, after 20 nanosecond, we have given A is equal to 1 and B is equal to 0. Okay. So like that, this way you can observe that only when A is equal to 1 and B is equal to 1, at that time we are getting output is equal to 1. Okay. So it is verifying the functionality of this particular design, simple AND gate design. Okay. Now, here you can see the one option is send selected object to target schematic editor, schematic tracer. If I click on this, it will show you your design, test bench design. Here, again I will show
Sir.
you. Here, this block-like symbol, send selected object to target schematic editor. On the right-hand side, on the topmost block, here you can see below the cadence, send selected object to the. देखा क्या वो? हाँ, if you click on that, नहीं वो साइड वाला, वो जिसमें ब्लॉक है मोहम्मद, इसमें वो ब्लॉक वाला है ना, हाँ.
Click on that one. Yes, please wait.
हाँ, उसको भी बताया. पूनम, click on that block like symbol.
Yes, sir.
नहीं किया है क्या? ये आया क्या? Schematic tracer. हाँ. Now here you can see the schematic tracer, and so my marker is at this point. Okay. So if you double click on that block, yes. Double click there inside the block. Inside the block you double click. अरे वो जो रेक्टेंगुलर आया है ना वहां पे डबल क्लिक करो. Okay, so here you can see that design under test is AND gate, and we have given name to that instance U1. Instance means independent copy of that AND gate. Okay, so now here you can see at 34 nanosecond. हाँ. तुमचा मार्कर दुसऱ्या ठिकाणी. So here you can see the marker is at point 34 nanosecond. Okay, so at this point my inputs are for design under test are 1 and 1. A is equal to 1 and B is equal to 1. Okay, so at that time I am getting the output 1. Okay, so here you can trace this. You can trace the input outputs like this way also. Okay, you can close this schematic tracer now. Yeah. You can close that schematic tracer. Gauri, you can close that. Yes. So you got the flow, means how to write a code and how to write the test bench. Okay. So again I will explain.
Yes, sir.
Now here you can see if I close all these things. Okay, design browser and this Steam Vision console also. Close that design browser only. Come to this window. All the waveform should be closed. Steam Vision console is also should be closed. Gauri, you can close the waveform window. Yeah, Gauri, close that. That is a design browser. Close that. Whatever the window you are seeing on my desktop, be up to that only. Okay. Now, you close that. Yes. Click on yes. Good. Yes. Now, open this G editor. Okay. Now create new document here. On the bottom side there is a G editor. Okay. You can open the terminal and again log in. तुम्ही ज्या फोल्डर मध्ये होता ना त्यामध्ये जा. राइट क्लिक करून टर्मिनल करा. G editor ओपन करा. G edit आणि त्या फाईलचं नाव द्या वाटलं तर कोणती फाईल दिली होती. वहां पे दिखाएगा, वो फोल्डर में दिखाएगा कौन सा है. ANDGate.v दिया था, स्पेस देके ANDGate.v कर दो. Okay, Now here you can see create new document. Click on that.
Click on create new.
Okay. So I have shown this for the data flow modeling style. So this is a data flow. Okay. So this is a data flow. I am commenting it data flow modeling. So one line comment with 2 slash. Okay. I can comment this data flow modeling. So now come into the untitled document. Now come into the untitled document.
Sir, can you please tell me the command what you have
That is a comment. That is a comment I have.
Comment.
And get dot read. Data flow modeling style. Double backslash.
This tab. Okay. You want to write. Please come. Then save.
Yes, save कर दो उसको.
Save करो.
Comment दिया बदला बस. Okay, now come to your untitled document 1. Okay. अभी यहाँ पे होगा, यहाँ पे अभी विंडो दिखाते हैं ऐसे. तो यहाँ पे अनटाइटल्ड डॉक्यूमेंट है ना आपका, उसमें आ जाइए. आ गए? अभी यहाँ पे अभी now I will show you the different modeling styles. So I will show you the behavioral modeling style of AND gate. Okay, using Verilog. Module AND gate underscore PAHV. Okay.
All of you please write.
Type what I have typed. Module AND gate underscore behave. Okay. Now here also I am taking the input A, B and output C. So A, B are my inputs. Then output C. Okay. Okay. Now, if I am to write a behavioral code, so for that purpose, I need to use a sequential statement, just like our C, right? C language, programming language. So if you want to write a sequential statement, you need to use a always block. Okay. So there are two types of blocks. We have seen initial block in test bench, right? Here you can see. So there are two types of sequential blocks present in the Verilog. The first one is always. And the next is initial. Okay. And there is a begin and there is an end to combine these statements. Okay. So there are the statements here. Okay. And always is used with some at and some signals will be there here. So this is called as a sensitivity list. Okay. Now, what is the difference between this always and initial? We have used initial in the test bench. Okay. So whatever the statement you are putting under the initial, execution of those statements will happen only once. So when you write, when you execute that particular code, when you simulate that particular code, or when you compile that particular, when you run that particular code, which consists of initial, so execution of statement will happen only once. Okay. And if you talk about always statement, so if I make this always block sensitive to A and B, for example, these are the inputs of AND gate. Okay. So initially the input for AND gate was 0, 0. Okay. And it get changed from 0 0 to 0 1. So now change on the input B. So input change from 0 to B. So whenever there is any change on these inputs, what will happen? The following statement will get executed. Okay. So execution of this block is repeated. Okay. And condition for that is what? The signal should be changed. Okay. So if there is any change on A or B, following statement will get executed. Okay. So this is a difference between initial and always. Okay. So for the procedural blocks, for the sequential statement, I am using the always statement. Okay. So here I will come into this, and in always block, the left hand side element, what is mean by left hand side element? So here if B is assigned to C, so this element, if you use C in always block, this should be of data type register only. You can't use this as a wire. Okay, wire data type, but you can use B as a wire because B is the input. Okay, but the left hand side of operand can't be the data type wire. It can only be used as a data type register. So what I am doing here, when we mention that input is AB and output is C, default data type for this is wire. Okay, so default data type is wire. Now these three are wires. Okay, so you can't use C inside the always block. You can't use this output C inside the always block. So we will use one register, internal register. So I'm using reg C underscore A. Okay, semicolon. Now I will use a always block. So always space add in bracket. So this always block will be sensitive to A and B. Okay. So whatever the statement you are writing in always block, that should be in between begin and end. Okay. So between this, I will write these statements between begin and end. Now, so I am using a case statement because I need to write a code in behavioral form. So case statement start with the keyword case. Okay. Then expression. So here I am using the concatenation operator. So what is mean by concatenation operator? This bracket, like curly bracket, is there now. So this is a concatenation operator. Okay. So concatenation operator means, I will just show you that thing. Here we can see. So concatenation operator means it concatenate two or more operands. Okay. So here you can see example for that. I have used this bracket for the concatenation operator, and I am concatenating or connecting these operands. Okay. So here you can see in example, A is 2-bit number, which is a binary. B is a 3-bit number, which is a binary. Similarly, C is a 2-bit number, which is a binary. Okay. So I have applied the concatenation operator on A and C. Okay. And if I assign this to D, so D will be having this value. Okay. So first C was 1 0, A was 0 1. So what value you will get? 0 1 1 0 in D. So B will be 4 tick 0 1 1 0. Okay. So like this way you are concatenating these things. So now A and C were 2-bit numbers. Now D will be 4-bit number. We have concatenated these two numbers. Similarly, here you can see for B, A and C. Now first C is what? 1 0. So here you can see 1 0. Then A is what? 1 1 0. Just wait. A is what? 0, 1, sorry. A is 0, 1. And then C is what? Then B is what? 1, 1, 0. Okay. So this is a B, this is a, and this is a C. Okay. B, A, C. Now if I assign this to D, D will be 7-bit number, will be having this combination. Okay. So like this way, you can concatenate using this curly bracket. So I am using that only here. Curly bracket for A and B. Now A and B will be concatenated, and that will be 2-bit number. Okay. So now I'm mentioning the conditions. Okay. So I'm representing first condition to tick B when A, B are 0, 0. Okay. So at that time, what will happen? C underscore A will be 0. Okay. Similarly, I can copy paste this and just change the conditions. Okay. So here I'm mentioning 0, 1, then 1, 0, and 1, 1, right? And for 1, 1 only, output will be 1. So I'm putting like this. Okay.
B00 is binary.
काय झालं?
2 complements B म्हणजे input आहे का 0 binary.
कॉम्प्लिमेंट नाही, नंबर स्पेसिफिकेशन
B
येते.
B B means
बायनरी.
binary.
तुम्ही थेरी लक्ष दिलं नाही, मग त्यामुळे तुम्हाला एक नंबर कळा.
सांगा ना.
थेरी सांगितली होती, त्यासाठी मी थेरी सांगत होतो, नाही तर कोड नाही करत. टू टिक टिक आहे नाही इथे.
तुम्ही आउटपुट कन्सिडर करायला आहे.
हां,
सी आउटपुट कन्सिडर आहे. ते कॉम्प्युलेट होईल ए आणि बी.
okay, have you written this? Good. Now you can use AND case. Okay. Then case is always ended with AND case. Okay, case is always ended with AND case. So this is very important. AND case is the parameter. Put AND case here after the defining the cases. So case should be always ended with AND case. Okay, Poonam, type it. Is it visible to you what code I have written here?
Yes, sir.
Just type it. Okay. You can copy paste that thing. So what, after copying the one statement,
कुठं गेली एवढी गेली कुठं सेविंग एवढी? मी तर 1 रुपयाने मागे तुम्हाला इतकी त्याचीच गरज 1000 टोटल सेविंग होती.
okay, have you written, Poonam? Do you facing any problem?
No, sir, writing.
Okay, write fastly. Okay. Then here we have ended case with end case. Now here you can see we have ended begin with end. So after after ending this, so C underscore is our internal variable, okay, internal register. Now that value we need to assign to our output C. Output C is a wire. That's why we haven't used that as a left side operand. Okay, left side variable. Okay. So here you can type assign. Then C underscore will be get assigned to C underscore A will be get assigned to C. Okay, type assign. So end case assign C underscore is to C and A and module. So we have written our code now. You can type end module there. Okay. So make sure that begin is ended with end, case is ended with end case, and module is ended with end module. Okay. And another important point, after the module declaration, module and get behavior, you have given the port. Okay. After that, after the bracket, you need to put semicolon. That is also very important. Otherwise, it will give you error. The first statement. After the first statement, you need to give semicolon. Okay. So good. So have you written, Poonam, all things?
Yes, sir.
Good. Now Control S and give the name and underscore and get underscore behave dot v and get underscore behave, or whatever you want you can give, but behave should be there.
Behave dot
V. Okay, written. What happened, Gauri? You haven't saved? Yeah, Control S कर दो, Control S कर दो. Yeah. Now put name and get underscore behave dot v. Then click save. Okay. So now here you can see the keywords are visible with the different colors. Now again create one new file. Now we need to write a test bench for this. Okay. So go to the untitled document. We need to write a test bench for this behavioral and get module. Okay. So module, start with the module, then TB underscore and get underscore behave. Okay. Semicolon. So my test bench module name is TB underscore and get behave. Right? You can give any name, but it is relevant to that. That's why I'm giving that. Now here you can see for AND get behave also we have used 2 inputs and 1 output. So similarly, input should be registers, register A, B, register data type, and output should be of wire data type. Okay. So after doing this, we need to instantiate that design under test. So what is the name of design under test? And get underscore behave. So you can just Control C and Control V that thing. Go into and get dot behave V file, or you can type it also, no issue. So I'm instantiating that point. So I'm putting U1 instance to that. And in the same order, I'm giving the input and output. So here you can see the order of input and output is the same. First 2 inputs are there, then 1 output is there. So like this way, you can put it. Then semicolon, end it. Good. Now we have taken that design under test. Now we need to apply the test bench inputs. So initial, make the spelling of initial clear. Initial begin. So I am first applying inputs. A is equal to 0, B is equal to 0. Similarly, you can apply other inputs after giving the 10 time units delay or whatever time units delay you want to give. Similarly, you just copy paste that so that within less time it will get completed. Okay. So we have used begin. So after that there should be end, right? नाही 4-5 condition दाखवायसाठी असं. Okay, so you can give all 4 conditions if you want. I have given only 3 here. Okay. So after this, begin should be ended with end, and module should be ended with end module. Okay. क्या लिख दिया क्या कोड हो गया? Okay, Poonam, have you completed the code? Shruti?
Yes, sir.
Yes, sir.
Okay, ठीक है. So Control S. Okay, type Control S. Then whatever the file name is there, give that tb underscore and get underscore behave dot v. Okay, save it. So now all things are clear now. Dot v is important. Dot v is important. Okay. Otherwise, now minimize this G editor. Now come to your NC launch. Here you can see 2 file gets added, right? Wait. 4 file gets added. So whatever the recent files you have done, that 2 files get added here in the directory section. Okay, on the left hand side. Now click on and get underscore behave and compile it. Launch Verilog compiler with the current selection. Okay, and get underscore behave. So is it verified correctly? Is it giving any error for anyone? Anyone got error? ठीक है, I will just check it.
Yes, sir.
So what error you got? You just check it. Sir.
Sir, mine is expecting and semicolon.
Now you check on which line it is showing that, on which file. You can check that and rectify it, try to rectify it. So just check it. Every line should have a semicolon properly. The first line should have a semicolon. Okay, all of you just listen that after the bracket. That is very important. Be careful about that. Now you control S and again try to compile it. Poonam and Shruti. Control S करा sir.
Yes, sir. Now the error has gone.
Dot v नहीं save करा sir. And get behave one dot v. Okay. So Poonam, which error you got? Have you got any errors?
Yes, sir. Sir, it is saying C underscore A equal to 1.
C underscore A is equal to what? So you just check it properly. Okay, let me tell you. A comma is there, okay? You know, always block A comma B. And now you save. Now save it and again compile it. Launch compiler. What upper one there is. I got stuck here. Launch compiler here. This launch Verilog compiler. Now you can click there. Not that. Just let me operate your PC. Now see again what you that got here. After the register you need to give the space, okay? After the register you need to give the space. Control S. Again go to the launch. Click on that and get behavior B and launch this compiler. Here, this is there now. Okay, Control S. Again go to and get behavior. Now it's working. Okay. So all of you got the output. ते #10 नंतर सेमीकोलन द्या. Okay. Now again, am I audible to you?
Yes, sir.
Yes, sir.
ठीक है. Now you can click on tb underscore and get dot behave dot v and just compile it. So do you got any error?
No, sir.
Poonam, you go to the NC launch, okay? NC launch window. Now you click on that and get tb underscore and get dot behave dot v. Do you got any error? Compile it. Do you got any error? Poonam, I am talking to you.
No, sir.
How to identify error? How do you know? There will be the red color like statements will be there. Okay. Otherwise, in the simulation, it will give us the error. Okay. सर एकदा चेक करा मग तिथे एरर आली होती. पूनम जे रेड कलर मध्ये आहे ना ते एरर दाखवतो म्हणजे ते कोणत्या फाईलला आहे कोणत्या लाईनला आहे.
Yes, sir.
ते प्रॉपरली पहा म्हणजे हे तर प्रोग्रामिंग आहे हे तर इम्पॉर्टंट आहे. ओके आता सर काय ती एरर बघा. Okay, ठीक है, I just check your code. Okay. Okay, now there is no error. Okay, this was showing the errors. Hello. Now all of you are ready with the correct file. Now here you can see in the work clip section on the left hand side, there is a test bench module get created for that particular tb underscore and get dot behave. Click on that, and here you click on elaborate. Okay, launch elaborator with the current selection. Launch elaborator with the current selection. So it got successfully. Yes. Okay. Now after clicking on that launch elaborator, you can see that under the snapshot there is a and get tb underscore and get behaved module is there. Click on that module. I think Poonam not got. Okay, Poonam, I will just show you how to. Okay. Okay, I'll just check the outputs of everyone and just show you that thing. तुमची फाईल कोणती आहे? त्याची टेस्ट बेंच कोणती आहे? बिहेव वन. नाही ही अँड टेस्ट बेंच आहे. ही टेस्ट बेंच आहे. याला टेस्ट बेंचचं नाव. ओके, हा याला करायचं म्हणून मी ते नाव तेच नाव त्या कन्फ्युज नाही. याला गेलो होतो तुम्ही. येतं की झालं की दुसरे सर्टिफिकेट सर टेस्ट बेंचच येते नाव त्यांना कन्फ्युज झालं बरोबर आहे. हा इथं तुम्ही गेले ना ठीक आहे अंडरस्कोर लॉन्च करायचं. तर तुमचं ना ते मॉड्यूल हेच कॉपी करायचं आहे. हेच आहे ना आणि गेट डॉट बी हे मॉड्यूल आपल्याला तिकडे घ्यायचं आहे म्हणजे त्याची कॉपी घ्यायची. ओके, तुमचं अगोदरच आहे अरे मेरे को थोड़ी ना पड़ा है सारे कैडेंस में खुद से सीखा. काही नाही ते काय होतं की तुमचे बाकीचे फाईल ओपन होते आणि त्याच्यामध्ये तुम्ही कंपाईल केलं असेल एखाद्याला आणि जसं इलॅबोरेशन चुकीने त्याचं झालं असेल मग काय होतं की एका युनिट मध्ये सपोज याला U1 नाव आहे तर याच्या ऐवजी तोच येतो. Okay. झालं का पूर्ण?
Sir, I have run the simulation.
Okay, so now it's ready.
Yes, sir, got it.
Yes, yes. Okay. Now you click on workleaf tb underscore andgate dot behave module under the snapshot section and click on this launch simulator with the current selection. So now this window will get open. Okay. So you cancel this Cadence Indigo window and open this. Okay. Now you click on this tb underscore andgate dot behave under the simulator section. Hi, Shruti, you close that Cadence Indigo. Yeah, yeah. So whatever the window you are seeing now, you just maximize it. Okay. Now you click on this tb underscore andgate underscore behave and go right click on that. किया क्या? हाँ. Go to the send to waveform window and you click on that. One window will open. So this is a waveform window. Now here you can see the play like button is there. Okay, blue color. I am just mentioning that blue color play like button is there. Click on that. So similarly here also we are getting the correct functionality for this code. Got it? So like this way you can create a design and you can simulate it. So next phase is like a synthesis phase. So whatever the code we have written, so that code will be get mapped to the hardware. Okay, that's very long process is there. So first you need to be equipped with the language very correctly, so you can write a code for that particular design. Okay, so for that purpose, now you close this. You check the functionality and first you check the functionality. Is it giving the AND gate functionality or not? Then you can close it. Yes. So we have seen behavioral style and which one? Data flow style we have seen. You can close, you can come to the G editor. You can close the previous files. Okay. Only one should be open, otherwise G editor will be closed again. And create a new file here. So now I will show you the structural modeling style for AND gate. Okay, how to write a code in the structural modeling style. You Shruti, you just open the G editor, your G editor. Gauri, sorry. Now Gauri, maybe G-editor is open at the bottom, I think.
It's a schematic.
काय झालं?
Sir,
Okay, so I will show you the structural modeling style. You just open your G-editor. So model and gate underscore structural. So I'm only mentioning struct here. I'm giving the same input like A, B, C. Okay, semicolon after the first statement. Okay, so here inputs are A, B, and output is C. Okay, so start writing this code. So all of you are there?
Yes, sir.
Yes, sir.
You just start writing the code. So I'm not observing any activity on your, that's why I'm showing that. Okay. So in the structural, what we happen, we take the gates and we just connect it. We take the inbuilt primitive, which is present in the Verilog. So for AND gate, there is an inbuilt primitive or inbuilt gate present in the Verilog. So you can type, you can use that using AND keyword. Okay, so for that I'm using an instance u1. So in the Verilog, while defining the port convention, for example, this AND gate is inbuilt primitive. Definition of that is available in the Verilog. Okay, so in that they first define the output and then they define the input. So for that purpose, first I am mentioning the output, then I am mentioning the inputs. Okay, so like this way. So first I have mentioned the output here C, then I have mentioned the inputs. Okay, so like this way you can do. So this is only structural modeling style. So here I am commenting it. So this is a structural modeling style. Okay, and after this end module. And this statement is concurrent statement. Okay, this is a concurrent parallel execution. So even if I write another and below this, so those both statements will get executed at the same time. Make sure that your first line should have a semicolon. It's very important. Otherwise, it will give error. After every line, there should be the semicolon. Otherwise, compiler can't understand. But for end module, you don't give any semicolon. Okay, for end module, there is a no semicolon. Okay, done. Okay, good. Now Control S and give the name and gate structural. struct also is there. Dot v is important. Dot v is important. Okay, save it. Now you write a test bench for this. You just write a test bench for this. So I can see that. Create one new document. So you know now how to write a test bench for that. Okay. So you write a test bench for this. So let me see this. You create a new document and just write a test bench for this. Yes, yes. So take a new file and very important, okay? So when you are writing a test bench for any design, it will be very nice that if you use a TB underscore before, because so it will be helpful for you to detect that it is a test bench file. So for this test bench, what I will write TB underscore and get underscore struct. Okay. So write a test bench. Poonam, Shruti, you write a test bench. For this, create a new document and write a test bench for this. And same procedure you follow, whatever we have followed before. Then we can conclude our this and then we can go for a break.
Dot v पण करायचं.
Oh, dot v is important. म्हणजे ती Verilog ची फाईल आहे.
सेव्ह करू.
Yes.
पण आता ह्या आपला कोड काय आहे?
जो मागत कसा लिहिला होता तुम्ही कोड तसाच टेस्ट बेंच साठी.
Hello, sir.
Okay, so which error you got?
Sir, it's saying input output port not defined.
Okay. So which file tv underscore and wait
Yes,
truck.p?
sir.
Open that
Yes,
file.
yes, sir. Just a minute, sir.
So tv underscore. Now here, Mohammed, very important thing. So
Yes,
this
sir.
is a test bench kind of thing. Okay. So you have designed this model na, and get underscore struct.
Yes, sir. Yes, sir.
So that only should be instantiated here. You are using here
Yes.
also inbuilt primitive. Understood? So
Yes, sir.
whatever the model you have designed using structural style, that you have to instantiate.
Okay, sir.
And now you can try to compile and do the thing.
No, sir, again, I have to change the sequence of the A, B, and C input output sequence.
No. Here you have given the inputs, right? First you have given the output, now then
Yes,
input. So here that is right only. C, A, B.
sir, when we have instantiated, that time the sequence is wrong, sir. It should be A, B, C, right?
No. What here you can see, this is the inbuilt primitive, means definition of this is present in the Verilog. In that they have mentioned output first, then input. Okay.
Then input.
So design this unit like this way. Similarly, when you are instantiating here also you need to give output first and then input. Okay.
Okay, sir.
Because
Okay,
of
sir.
that we are giving like that. So if you go to NC launch, have you saved that
Sir,
file?
save. Yes.
Yes. Now, if you go to NC, this is only not TV underscore and get stuck. If
Yes,
you
sir. Yes, sir.
compile it, okay. So, like select this and compile it. It is giving the error. Port C not declared as a input, output, or in out.
Yes, sir.
So
For all the
T-
ports, it is giving same error, sir. A, B, and C.
Okay. So here you can use what they are doing. They are mismatching that with the. So here you can use XY. Okay. So
Okay,
in
sir.
here, what you have done. So instead of ABC here, you can use XY variable so that it will not get confused with that. Okay, X, Y, and Z, and then you do it. Okay. Similarly, Poonam, instead of ABC here in test bench, you can use input X and Y, and output you can use Z. Okay, and similarly, you can make those changes in this code.
Okay, sir.
Okay. So Shruti, are you there? You gone.
Okay, is it giving the same error, Mohammed? Okay, you close this previous one and get TV underscore and get the and here you haven't changed now here. Here you need to change Z, X, and Y. Then Control S. Now if you do the what is showing TV underscore and get underscore struct, but we have changed now. Here also we need to change X, Y, and Z. Okay, Control S. Now if you do this, it is not declared. How it is happening?
Sir, instead of register and wire, what if we declare input and output?
No, no, no. Because here we are only giving the inputs now in test benches. We are not giving. We are not designing our unit.
Yes, sir.
Okay.
Yes, sir.
That's why we are just. This file is like that only. Output should be came. What's the XY set and get underscore struct. Let me copy this. Let me. Okay. So all XY is there. Initial is there. So positional ZXY only. Control S. If I go to the NC launch again, I go to TV underscore and get struct. Okay, what else? Okay. Okay. So you just close it and launch it again. So maybe it is. Yeah, what happened is code is correct only. This is your and get struct file, Mohammed. Which one is and get struct?
Yes, sir. This one only, sir. This is my yes, sir. This one. Structural modeling style.
Okay.
And this one is the test bench.
What is showing? Things are correct only. Yeah, clear. Now what happens? Generally, in some compilers, what they do, if you use the Xilinx compiler, even if you mention port to TV, because generally test bench don't have any input and output ports. Okay,
Okay,
so
sir.
even if you put that in ports here, some compiler may accept that, when this compiler was not expecting. That's why don't give any port to test bench file. Okay, so that's why it was giving the error. Okay.
Sir, but in earlier modeling styles, like data flow and behavioral, it was accepting, sir.
No, I haven't given test bench. So if you see the AND gate here, you can see
Right, sir.
test
Right.
bench
This was
AND
the
gate.
mistake.
Similarly, if you saw for behavioral here, okay.
Yes. Okay, sir.
ठीक है